In Lesson 5.1, now we're going to look at example 5. You'll notice that we have an equal sign here. We're now going to be solving some equations with exponents. So you'll notice that we're going to try to get the variable alone. So we're actually going to work backwards here. If I look at this part B on the triad and I have p to the fourth, I'm wondering what number could I put in for p or substitute in for p, take it to the fourth power, multiply by 2, and get 162. Now this one isn't designed to be super tricky. You might be able to guess and check. But let's think of how we solve regular equations. If it's p to the fourth times 2, I'm going to divide by 2 to get just that p part left on the left side. 162 divided by 2 gives me 81. Now this is asking what number multiplied by itself 4 times makes 81. You may be able to guess that it is indeed 3. 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 makes 81. One way we can do that, though, because we've been working with these radicals, is we could take the fourth root of both sides. And if I do that, that's the same thing as thinking like this out loud. I will then say p equals 3. But let's not forget that negative 3 times negative 3 makes 9, times another negative 3 times another negative 3 makes 9. This actually could be plus or minus 3. We actually have 2 solutions for this triad. Now let's move to part A. Our first step, we're going to divide by 5 in order to get our x to the third all by itself. And 320 divided by 5 gives us 64. So we're looking for a number times itself to give us 64. That's our thought process. Now you may or may not be able to guess that that number is going to be 4. But let's think of it how we're going to cancel out, if you will, that third power. We're going to take the third root. Because remember, this would be x to the 3 over 3, which is just x, and that's what we want. So if we take the third root of the left side, we're going to take the third root of the right side, and the third root of 64 is just 4. Now on this one, note it could not be plus or minus, because a negative 4 times a negative 4 would be a positive 16. And times another negative 4 would give me a negative 64. We did not want a negative 64. This time, there's only one solution. So in a quick pause right here, your e-learning quiz today has a question that follows this video asking you why part A only has one solution with an x equals 4, but part B has 2 solutions, p being 3 and negative 3. Take a second to answer that question now. Now just to polish off and finish this example, we're going to divide by 2 on our example 5, and that means x to the 5th gives me 32. I can think in my mind what number times itself 5 times makes 32, and you can still do that. But if I take the 5th root, that would again tell me that x will equal 2. Think about it now. 2 times 2 times 2 times 2 times 2 gives us 32. Would we want this to be a negative? Think about it. But in this case, our only answer, you should have thought, nope, negative would give me one too many odd numbers. I only want it to be a positive 32. So in summary, we can expect that if you're trying to solve these with an equal sign, you're going to take any x to the n and take the nth root of it, make your index n, and you will have your x equals the nth root of your radicand.